Hello, my name is Heather Lee, and I am in the Fall 2021 Texas Tech Anatomy and Functions of the Visual System in Dr. Whitman's class, and I am going to explain the eye model to you. I was able to go onto Amazon and find an awesome eye model for $27, and this is fantastic because I am a hands-on visual learner, so thank you, Amazon, for that. So let me point my camera down so I can show this to you. If I can get out of the way. Okay, so on this eye model, we have this clear covering, which is called the cornea, and it is a transparent protective layer and is the focal strength of the eye. Blood vessels are not found in the cornea, and nourishment and oxygen received come from the aqueous and the tears. The conjunctiva is a clear membrane that covers the sclera and it lines inside the eyelids. The sclera is the white portion, is the tough white fibrous layer, and is a protective layer. So literally when people say, show me the whites of your eyes, this is what they're referring to right here. Okay, let's moving on to the muscles and the extrinsic muscles. This top layer here is the superior rectus muscle, and so it helps you roll your eyes upward if you're looking towards the stars at night. And this muscle on the bottom is the inferior rectus muscle, and that will help you look downward as if you're looking at your shoes. The medial rectus muscle will roll your eyes towards your nose, and on the opposite side is your lateral rectus muscle, and that rolls laterally away from the nose. So when we're talking about the segments of the eye, when I refer to the front of the eye, this is the anterior segment, and when I'm talking at the back of the eye, that is the posterior segment of the eye. So let's talk about the layers of the eye when we open it up here. Hopefully you can see those different colors there. That top layer is the sclera that we just talked about earlier, that white tough fiber. The second layer down is the choroid. That's the second layer underneath the sclera and the blood vessels that provide the nourishment to the retina. The retina is the third layer, and it's the inner lining of the back chamber of the eye, which contain the photoreceptors, and they're composed of cones and rods. Cones provide the detailed vision and the colored vision, and the rods provide the night vision and the global movement. The ora serrata is where the retina ends, and the choroid layer can be seen. So if we're looking inside the eye model, this large ball here is called the vitreous humor, and that is a clear-like jelly substance that fills the posterior segment behind the eye, and this takes up 2/3 of our eyeball. So if we're looking at the inside of the eye model again, this portion right here that goes all the way around in a circle is a ciliary body, and it is attached to the iris. It is a muscle that controls the focus. Another word for focus is accommodation of the eye, and it causes the lens to change shape. So if we are going to look at an object up close, the ciliary body right here is going to contract small, and the light is going to bend to see the object, so this lens is going to get thicker or bigger. But if we want to look at an object far away, the ciliary body is going to relax, and the lens is going to accommodate to a thin position so we can see that object far away. So talking about the lens, this is a transparent structure of the eye that focuses light by changing the curvature from thick to thin. So in Dr. Hartung's video, he talks about when we age, how the lens gets more brittle and less elastic. So when it contracts, it doesn't rise up as much and like it used to. And so that's why older people like myself, we have a tougher time reading. So that's why we resort to readers. And then I know in my 40s, I used readers, and now that I'm in my 50s, I use bifocals, and I couldn't read without them. So I'm very thankful. Okay, the suspensory ligaments are long, thin fibers which connect the lens to the ring of the ciliary muscle. So if we are going back and looking at all this together, we have the cornea, which is the protective layers of the eye, and the curvature provides the focal strength of the eye, and it is the only transparent tissue in the body. There's aqueous humor. This is a watery fluid that fills the anterior chamber of the eye, and it provides nutrition to the surrounding areas. The canal of Schlemm, this is where the aqueous fluid is removed in the corners. If the canal is blocked here, you can have glaucoma because it can't be released, and it creates all this internal pressure on the inside of the eye, and this puts pressure on the optic nerve, causing damage and blindness. The iris right here is the beautiful color of your eye. So your iris can be brown, green, blue, hazel. This pupil controls the amount of light that enters the eye by enlarging or minimizing the size of the pupil. The pupil is right here in the center. I used to think that this was just a black colored dot, if you will, but it is not. It is an actual hole that you cannot even touch. So it's a door to which the light enters the eye. Excuse me, that's my timer. So moving on, if we go back to our model, back here at the very posterior segment of the eye, this right here would be the macula. This is the center part of the vision. It's a small thinned out area of the retina consisting of photoreceptor cells that provide high quality vision acuity. The fovea centralis is in the center where 20/20 vision is at the center of that. The cones detect color of light, colors red, blue, and green. The most common is the red-green color of color blindness. My husband has red color blindness. The optic nerve is back here. It's a bundle of fibers carrying vision-related impulses from the retina to the brain to create the image. And the optic disc is the blind spot, the head of the optic nerve, the area where the optic nerve leaves the eye, leaving a blind spot on each eye. So that's it for me. Thank you so much for joining me. I hope you learned a lot.